Optical Associates model J500 visible mask aligner. This, the wavelength range of this instrument is 365 nanometers to 400 nanometers. The system is controlled by the PLC. The system operation is from a home-run PLC, which is inside this enclosure. And the PLC turns on and off all the solenoid valves for the operation of the system. To turn on the power, turn on the power on button, and soon the power button is turned on, the tower will swing to this position. That is, the lamp housing hood will come on top of the mask holder. So it is important to make sure that nothing is on top of the mask. Then press cycle button. The tower will move for the mask holder access position. And in case if the substrate vacuum is not on, and if there is a substrate on the chuck, it will stick to the mask. So load a substrate on the substrate holder and turn on the substrate vacuum, and lower the mask frame by using this red button. I have connected the facilities to the system, 60 to 70 psi compressed air and about 10 psi nitrogen. And the nitrogen bottle is turned on and it is flow is indicated. Now so the mask is currently mounted on the mask holder frame, and there's a switch for the mask vacuum. The mask is held under vacuum through this vacuum line. So the mask, the pattern should be on the bottom side of the mask. That's how it should be mounted, because the substrate will so when you turn on the mask vacuum, you have to check the mask vacuum meter so that it should be close to the system vacuum level. So this indicates if it is not equal, that means there is some leak. So now it is good. Turn it off. The substrate, the system vacuum is about 25 inches of mercury. And I turn on the mask vacuum and the vacuum level approaches 25 inches. Just to secure the mask, these brackets have to be connected using the thumb screws. Now, in order to proceed with the operation, press the cycle button. There is no lamp in the cycle button, and the microscope will be moved to the alignment stage. There are two push buttons on this cubicle block here. There are two push buttons here. The top one releases the y-axis motion, and pressing the bottom one will allow the x-axis motion. So for all same thickness wafers, first time the ball lock push button, which is over here, we have to press it and rotate the knob till the substrate comes in contact with the mask. Excess rotation of the z-axis knob will dislodge the mask. The mask will be lifted off its vacuum chuck holder, and the mask vacuum will start to drop a lot. So it's at about 50 microns here. The chuck is lower, and if necessary, you can turn on the contact vacuum and try to adjust the contact adjust. Typically, it is normally operated between 5 to 7 inches of mercury. For hot contact, turn the knob clockwise and the contact vacuum level will increase to 10 to 12 inches. Now when the vacuum increases, the nitrogen flow will go down. Now in order to proceed with alignment of the substrate, the contact vacuum should be off, and rotate the z-axis knob counterclockwise by about 20 microns, which separates the substrate and the mask. And now use the x-axis knob to move the substrate left to right, and the y-axis knob to move the substrate along y-axis, or the theta knob to rotate the substrate with respect to the mask pattern. I'm moving the substrate with respect to the mask. This is the y-axis movement and the x-axis movement. And when we move theta, the movement is barely visible because of I'm zooming out using the microscope zoom now. Here is the arc lamp power supply. On power up, these LEDs will turn on, that's the power indication. And I'm turning on the lamp. And it'll take about 10 to 15 minutes for the lamp to stabilize. So the initial voltage will be low, but as the lamp heats up and the current and voltage levels stabilize, the voltage level will increase and the current will decrease. It's a 200 watt lamp, and there are different modes of this lamp operation: constant power mode and constant intensity mode. When in constant power mode, the knob on this right hand side will allow to change the power level from 200 watts to 175 watts. The usual idle power is about 170 watts. So when the mask liner is not in use, but we want the lamp turned on, so 170 watts is recommended. And in constant intensity mode, there are two detectors inside the lamp housing for 365 nanometers and 400 nanometers, and the power meter can indicate the UV intensity in milliwatt per centimeter square, and there are calibration part and set point part, which is adjustable, and these parts can be turned on only when the lamp shutter is open and lamp is fully stabilized. So each channel A and channel B, can be defined and calibrated using an external meter at the mask surface or at the level of the substrate. We have to select the channel A and measure the intensity with the shutter open at the substrate level, and adjust the calibration part to match the intensity reading on this meter to the external meter. And we can pick if the detector on that external meter is 365 nanometer, then channel A is 365, and the channel B can be selected, and the intensity should be measured with a 400 or 405 nanometers, and the intensity measured should be calibrated by using this calibration part. Once the calibration is done at about 190 watts of this lamp power, now the set point can be used to set the intensity level of the UV radiations to the desired value. If, for example, if it is say 10 milliwatt per centimeter square, by adjusting the set point, we can increase it to 12 milliwatt per centimeter square, or decrease it to 8 milliwatt per centimeter square using the set point only, and that will help to reduce the power to the lamp using intensity of the UV energy. So after the alignment of the substrate pattern with respect to mask, press the cycle button once and set the timer to the desired level in seconds, and this over-on timer will enable the shutter to open for the set duration. So at any point of time, if you want to manually open the shutter, the expose test button can be used. If you want to skip the expose cycle, the skip button can be used. And to power up the unit, this power up red button is to be used. There is an emergency off switch on the left hand side of the exposure system. In case of any emergency, the EMO stop switch should be used. Alright, let me grab my meter. This is the intensity level at 365 nanometer, and and 17.2 milliwatts per centimeter square is the intensity level at 405 nanometers. The intensity level can be optimized using the knobs in the lamp housing to adjust the uniformity and power level or the intensity level of the UV rays. The system requires a facilities exhaust connection, and there are adjustments for the compressed air and nitrogen and the pneumatic panel. And the system is mounted on vibration isolation tables, and each bellow, there are 4 bellows under the table. The pressure in each bellow can be adjusted. Regulators for the front left, rear left, front right and rear right, the vibration isolation bellow feed under the system. The pressure should be adjusted in such a way the stable feed which are here should not be touching the floor. So at the final site, if necessary, any aluminum plate can be used to lift up the bellow a little bit. When the unit will be shipped, these bellows will be disconnected